classes. I think we're live. Ollie Jing is currently he's got matters to attend to, so he'll be back in a few minutes. But I guess I'll host you guys for the first bit. Oh my god, it's so loud. Okay. Okay. Can I get chat up? Okay, we have chat. So today we're gonna be doing 2023 C3L6. Let's just go. I guess it's important to have one of these calcs. It's very calculator heavy paper. So I'm also gonna need a periodic table. So can we rotate this? Hello. Rotate. Okay. It's not letting us rotate. Whatever. Okay, so this question is about electron counting and curly arrows. I've not seen this paper before, so going into it blind. So, blah blah blah. Chemistry is all about electrons, since bonding attractions are formed as electrons are transferred or shared between atoms. At all stages, electrons must be accounted for. Electrons are never created or destroyed in chemical reactions. If an isolated atom has the same total number of electrons as its atomic number, it is a neutral atom. Otherwise, it's a charged ion. Only electrons in the outermost shell, the so-called valence shell, are used in bonding. The number of electrons is equal to the period number for 1 to 12 and the group number minus 10 for elements in groups 13 to 18. So, okay, that basically tells you all you need to do. How many valence electrons do each of the following atoms have? So, chlorine. Now, it's a shame I can't rotate this. Oh my god, please. Okay. I can't rotate this, but chlorine is here. Bro, can Ollie Jing please come instead of sending the link? So, chlorine is in group 17. So, 17 minus 10 is 7. So, there's 7 valence electrons. So, that has 7. Strontium, I'll just quickly do this. Strontium, as you can see, is in group 2. So, that has 2 valence electrons. Neodymium, I'm pretty sure, is 5. Right? Yeah. Xenon is a noble gas, so it's got 18. It's group 18, so there's 8 valence electrons. Now, how many valence electrons do each of the following ions have? Now, this is where some people get confused, and where I get a bit confused. When it says 2 minus, you don't have 2 less electrons. You have 2 more electrons, because electrons have a negative charge. So sulfur is normally has a valence of 6 electrons. 2 minus means there's 2 more electrons, so that means there's 8. Okay. So as we're going through, just make sure to like and subscribe to support the channel so you can bump up more of these really exciting streams. Yeah. Okay. I thought you weren't listening. Now, let's look at O+. Now, O is in group 16, so it's got 6 valence electrons. And so O+ has 5 electrons. Is that right? Yeah. N+, okay, I'll just quickly do this. Where's TL? TL's there. That's group 13. There's 3 electrons. 2 boron 0.
How do you know TL?
Huh?
How do you know TL?
Because I looked at the periodic table. It's right here.
So that's 3 minus 1 equals 2.
Is this right?
Yeah.
Okay. We've got 4 people watching. You know, if you have any questions, you can ask in the live chat, and our C3L6 specialist will answer these questions. So, in molecules, individual atoms may often be shown with charges, such as the oxygen in H3O+. Such charges are known as formal charges. They are a result of how we allocate the electrons within the species. If it is assumed that each bond represents a pair of electrons shared equally beyond 2 atoms, the oxygen atom in H3O has 3 electrons used in bonds to the hydrogen atom. So together with the lone pair, the oxygen formally has 5 electrons around it. To clarify, a shared pair of electrons counts as 1 electron to each atom, whereas a lone pair, both electrons are with the atom concerned. Okay. Since an oxygen atom needs 6 electrons in its valence shell to be neutral, if it formally has 5, it must have a charge of +1. The problem with this model is that the assumptions that the electrons are shared equally. They're not. Since oxygen is more electronegative, the electrons in each OH bond are more associated with the oxygen rather than the hydrogens. In fact, calculations suggest the oxygen atom in H3O+ actually has a slightly negative charge. Okay. So, right. Which of the best describes the charge on each hydrogen atom in H3O+? Now, you know, I actually have no idea. So, let's just think about it. So there's 2 electrons. Let's say n of the electrons goes to the hydrogen. And
you like Subway Surfers on the side.
Okay. And 2 minus n. By the way, one thing I've noticed is you need to speak a bit louder into the thing.
Okay. And 2 minus n.
2 minus n. It goes to the oxygen.
What's n? Is that an electron?
And n is the electron. N is how much electron H has.
You can. I think that would work.
Yeah.
Yes, you can
So,
try it.
So the oxygen has too much. So because it has a slightly negative charge, the oxygen is the charge on the oxygen. The oxygen's essentially has 6 plus delta electrons.
Okay, what's delta?
It's like a small.
Why don't we say that delta equals 0.3?
I'll call it delta. And but the thing is, the oxygen has 2 minus n times 3 plus 2 electrons. Kind of. Which is 8 minus 3n.
Yes.
Equals 6 plus delta.
Wow.
So 3n equals to 2 minus delta. So n equals to 2 minus delta over 3. Okay. So now what we have to think, what's the charge on the hydrogen? Well, the hydrogen is supposed to have 1 electron. So 1 minus 2 minus delta over 3 is equal to a third plus delta over 3. So it's like at least 1 over 3.
Yeah. Okay, that was kind of dodgy.
Is it wrong?
No, it's right, but I'm just saying how you did it was a bit dodgy. I mean, no, it's not dodgy. Obviously, it's right, and like all the lines are right. But I feel like you could probably just have guessed.
So you're calling me dodgy for not guessing?
Yeah.
Is that what you're saying? So we have here's the C3L6 experts. Guessing saves time.
It does.
And time is very important, as we're gonna find out, because we're gonna run out of time before Freezies. Okay.
Can I just explain this quickly? I think this is how I do it. So the total charge is obviously +1, isn't it, of H3O? And if you consider the individual atoms, it's going to be 3 times the charge on H plus the charge on O equals the charge on H3O plus.
Wait. Say that again.
So 3H plus slightly negative equals 1 plus.
Oh, fine.
So
Okay.
3H equals 1 plus something.
Okay.
So H is at least 1.
Okay.
But, okay.
Sure.
1/3. I mean,
I remember when I was in first year, I was not getting this. Add the formal charges to the non-neutral atoms in the following structure. N neutral minus NX. Okay, we should probably read this. Calculate the formal charge by doing the neutral atom, how many electrons the neutral atom has, minus how many electrons it actually has. And you just split the electrons equally. Do you split the electrons equally?
yeah.
Cool. So the formal charges, okay. Now this O actually has 7 electrons, but it's supposed to have 6. So I'm gonna say the formal charges are 1 minus.
Yeah.
Now the S.
Well, you could just write minus.
Okay.
Or like, yeah, minus.
Alright, -1 and +1. Okay. That S is 5. Yeah. Ozone. 1, 2, 3, 4, 5. So this is -1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Wait, this is supposed to be +1. Oops. +1, -1. Because it's 6 minus 5, 6 minus 7.
Yes.
Am I doing an alright job of explaining it?
Yeah.
Okay. You know what? I'm just gonna do these because why not? Wait, no. What am I doing?
Yeah. So I mean, another way to think about it is by looking at how many bonds it has. So it's kind of like a dodgy method, but this is how I do it most of the time. Just because you don't need to like count the electrons. But for example, if we take oxygen, it normally makes 2 bonds in like a molecule. But if it only makes 1 bond, then it'll have a charge of minus, like in carboxylic acids.
Wait, jeez. For this part,
Yeah.
I said a sulfur. Where did the electrons go? Because sulfur has 6 electrons. So is there no lone pair? Is there no lone pair?
Well, I mean, it's not showing any lone pairs.
Okay, so I'll put +2. Okay.
Yeah.
Wow.
I mean, if it was +1, -1, you could just write plus or minus, like how they've done. But
Alright.
yeah.
Oh, is someone giving love in there? Okay. So, I think for this question, you just had to read the question. Add all the lone pairs to every atom in each of the following structures. Oh, hell no. Okay, so the O is supposed to have 7. So I'm gonna draw some lone pairs here. Okay.
Yeah, that's correct.
And the sulfur is supposed to have 5. So I'll just draw a lone pair there. Okay. Oh wait, there's lone. Okay.
Yeah.
And the oxygen.
Mm.
Let me think about this.
Mm.
I think the oxygen would have 2 lone pairs.
Mm. Yes.
Because it's making because it's using the 2 other electrons to form bonds.
Yes.
Or something like that. Something like that.
Precisely.
Okay. Cl. If it's Cl plus, there's 6 things. So I'm gonna put 2 lone pairs.
Mm.
And the O, I'm gonna put 3 lone pairs.
Mm. Yes.
And 2 lone pairs.
Yes.
This O gets two lone pairs.
Mm.
So we can see a bit of a pattern. The O minuses will have three lone pairs.
Mm.
This N, I think, doesn't need any lone pairs because it already has 4 bonds.
Yeah. Okay.
This is kind of tiring, bro. Oh, wait, is phosphorus group 5? I'm gonna assume, yeah.
Phosphorus is group 5. Yeah.
Nitrogen needs a lone pair. Needs a lone pair. Needs a lone pair. Is that right?
Yes.
Okay. So far, let's. I don't think they can see. Other structures. So there are often different ways of drawing structures depending on how we consider the electrons to be allocated. There are pros and cons. Some structures might suggest unrealistic charges. Other structures may break the octet rule. Curly arrows may be used to show formally the movement of electrons. How it is possible to interconvert structures. The arrow where the electrons are.
The arrow starts where the electrons.
The arrow starts where the electrons are, and the head shows where the electron pair ends up. Usually on an atom as a lone pair, or between two atoms as a new bond. You see, they're using algebra. They're using algebra to put the charges. Right. Okay. Yeah. The curly arrows. So for example, here the lone pair is making the bond, and the bond is making a lone pair.
Yeah.
Okay. The special double-headed arrow is used to indicate the structures are the same, but just with their electrons distributed in a different way. Structures A and C make an equal contribution to how the real molecule is, since they are the same but reflected. This suggests each SO bond is perhaps between a single and a double bond, so you draw the dotted line, and the charge on each oxygen is actually the same. Structure B shows a different way of assigning the electrons, but suggests there are more than 8 electrons around the sulfur. This is acceptable for elements in period 3 in the periodic table, but not elements from period 2. Elements 3 and below.
Yes.
There's so much text, bro. Curly arrows are particularly useful for understanding the redistribution of electrons during chemical reactions. Consider this hydroxide, the reaction between the hydroxide ion and the ethanoic acid. So the lone pair goes onto the H, which makes a bond between the O and the H, and the bond goes to the O, giving it a lone pair. It turns out that the two CO bonds in ethanoate. I saw I've literally seen this picture drawn drawn so many times. What was it like? Keto enol, whatever. Is it like this?
It's kinda, yeah.
Okay.
Like one of the oxygens is a carbon.
Okay. All right.
Yeah.
In reality, the ion is more like G with equal charges on the oxygens, but not exactly 1/2, since the oxygens still pull more electron density from the carbons and even the hydrogen atoms in the ion.
Damn.
Draw the curly arrows and any necessarily lone pairs to convert structure E to structure F. Okay, we're finally doing a question.
Okay.
Okay.
Let's do this.
So, as we saw, the O minus requires 3 lone pairs. The O, it's just 2. And we can clearly see that we're breaking. And I guess let's draw the lone pairs here. There's 3 lone pairs and 2. So that suggests a lone pair is going from somewhere here to somewhere here. And I guess this goes over here. Are they gonna be strict on drawing curly arrows?
No.
Okay.
Well, in this question, they're probably expecting you to draw the lone pair, but
it's like where the curly arrow comes from and what route it takes and whatever BS that like Chess talks about. Whatever.
there are some things to just like take note of, but they're not that important when you're doing like going from a bond. But I don't think that's very relevant.
Is this fine?
Yeah, that's fine.
Okay, that's fine. Okay, hydroxide ion can also deprotonate propanone from the enolate ion chain. Okay. The enolate ion is better represented with the negative charge on the oxygen rather than on the carbon. Use curly arrows to show how J may be converted to a form with a charge on the oxygen. Okay, so to be honest, I think it's gonna be like this.
Yeah.
Is it like the same?
It's the same.
Oh.
But you gotta draw it.
Okay, here we test if I can actually draw things. So we have the lone pair here. That goes there. That goes there. Oh wait, we need to draw the lone pairs.
No, you do. Oh, we do.
Oh no. But,
Yeah, just draw the lone pairs from the carbon, because that's the source of the electrons. But for oxygen, you normally do it.
And then it's gonna be like blood. I'm assuming it's like this.
Yeah. Yeah.
CH2.
Yes.
There we go. How do you think the CO bond in the enolate ion compares to that with the ketone? Wait, this is the ketone, right?
Yeah.
Oh my god.
What do you think?
Well, I'm thinking about it, right? And like C double bond O is a double bond.
Yes.
There's more bonds.
Yeah.
So I think it's gonna be stronger. The keto is stronger, so the enolate is weaker.
Yes.
Okay.
Exactly.
Okay. I also know that the enol form is less favored than the keto form.
Ooh. Okay.
I think. Is it?
Depends on the like molecule.
Fine. How do you think the carbonyl CH2 bond strength in the enolate ion compares with that in the ketone? What's carbonyl C? Is that the C double bond O?
The carbonyl C CH2 bond strength.
So is it like this?
Yeah.
This as the carbonyl C. Okay, so like this bond versus this bond. And low key, if this is weaker, then I think in the enolate it's a double bond, so I'll say stronger. Okay.
Okay.
Damn. I'm so much better at chemistry when this guy's sitting next to me.
It's just the effect. Okay, come on.
Okay, guys, we're getting backseated here. Like, subscribe so we don't get backseated. Okay. I think Juice regrets hopping on.
No, it's fine. Let's carry on.
Even though there is more electron density in total on the oxygen, most of the time the enolate ion acts as a nucleophile, attacking from carbon. Circle the best reason for this.
We should put some music on.
I was considering that, but I couldn't be asked, bro. Oxygen is more electronegative than carbon. I know, man. The electrons on carbon are higher in energy than those on oxygen. True that. I don't think that the carbon would be more of a nucleophile if the electrons were lower in energy. So I'm gonna remove option C. Most of the time, I say nucleophiles are
Mm.
better if they're more electronegative. So I like because
Okay,
they're
what if
they're electron rich. They're electron rich.
Well, if they were, then it would attack from the oxygen instead of the carbon, because oxygen is more electronegative.
Yeah.
Yeah.
Yes. So I think it's V.
Okay. Yeah, it is.
It is. Can you provide better logic?
Well, the electrons on carbon are higher in energy than those on oxygen. So,
But wait, but why? But why?
because carbon is less electronegative than oxygen.
Oh, fine.
Because if you think about if
Yeah.
oxygen is more electronegative, then that's kind of because that if the electrons go near the oxygen, you can think about it like if the electrons are near oxygen, they'll have a
More-
lower energy.
Yeah.
So it sucks in the electrons. It's like a hole in
Yeah.
the energy.
Am I right in saying that nucleophiles are better if they're more?
I mean, in this case, most of the time it attacks from carbon, doesn't it? So the carbon atoms are better nucleophile.
Oh, right. So if it's okay.
I mean, it depends on like this goes into like the hard soft thing that Holly was talking about in chemistry. So like you can be a hard or a soft nucleophile. And oxygen is a harder nucleophile. And carbon is a softer nucleophile.
Okay.
But yeah.
Okay.
Anyway.
We frauded our way to the.
Oh, also, this is a challenge. So you know in carboxylic acids, it looks like this.
We have 1.5
Okay.
hours and Bruce talking
Looks
about
like-
challenge.
But if you
Okay.
you can make it into
You can't. Don't draw up here.
okay. You can make it into ethanoyl chloride. Do you think this is more reactive?
This.
Yeah.
Do I think it's more reactive? I'm gonna say yeah.
Well, it is.
Yeah.
It is.
I mean, there's hydrogen bonds here.
Yeah, but that's I guess that's part of the reason. That's not the main reason. But what I'm getting to is if it's more reactive, then surely it'll be easier for something, let's just call it a nucleophile Nu, for it to attack this bond, for it to attack the CO double bond.
Mm-hmm.
So you would expect it to be weaker
Yeah.
than in carboxylic acid. But it's actually stronger.
What's stronger?
The CO bond
Oh, right.
is stronger than the double bond in the carboxylic acid. So can you draw that to explain why?
This.
Can you draw a resonance mechanism to explain why it's stronger? Come on.
What's a resonance mechanism?
It's just what you did earlier. Twice.
What's the resonance mechanism?
No, it's just, that's not an actual thing, but it's just the name, it's just a mechanism that converts one resonance form to another.
Is it like that weird dotted line thing between that?
That's the resonance forms, but you
Yeah.
can convert them between each other. So how do you show it?
Wait, but like,
Is it like when there's like a double bond and you want to show it between two like bonds?
Yeah.
Then you draw like a little dotted line like between the bonds.
It's a double header arrow.
so you want me to show that the C double O bond is stronger here?
Yeah.
Because you
Mhm.
can't have a double bond to the Cl,
Okay.
but here you can have a double bond to the O. So like the charge is split between the O's.
Yeah, but there's a reason why this is stronger. I mean, okay, fine. Compared to that, this is still stronger.
Yeah, because you can have a double bond to the C, but you can't have a double bond to the Cl.
Okay.
Okay.
Still stronger.
Do you want me to draw something on here?
Yeah. Draw the curly arrows.
Um, like
Where can it come from?
the here.
Okay. Okay, that's actually a very good start.
So okay, let's draw a curly arrow. Like it does it come from this?
Yeah.
Does it actually?
Yeah. Where
Does
can
it-
I go to?
They can go to here
Yeah.
to make a triple one.
Yeah. Okay, and then what happens?
Mario. And then I guess we can do this.
Yeah. So what does it make?
This makes triple one O.
Okay.
Is that wrong?
It's not wrong.
And you have CL minus.
Yeah.
And,
How many electrons does it have? Yeah.
Okay.
That's it.
Is that it?
Yeah. So it's actually nearly a triple bond. It's between double and a triple bond.
Wow.
But it's still more reactive. But we can go on to that in another day.
Yeah, I think that's a good idea.
Okay.
Have you heard of C triple bond O? Yeah.
You will have you
C triple bond O.
Yeah.
plus.
I
It's
guess.
gonna be next year. We're gonna learn about it. How you add it to a benzene. You can add that to a benzene. Yeah.
Okay, so let's think about what happens here. There's a bond formed from the C, so it's gonna be like it's gonna be something like this, I swear.
Yeah. Exactly.
Great.
Okay.
What the fuck? Oh, this is the last page. The last page of TS.
Yeah.
Let's go. Are we actually doing okay for time? Surprisingly. The synthesis starts with a hydrocarbon denoted LH, which is deprotonated using a strong base to form anion L minus. Oh no. Do we have... Okay.
Blah 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 blah. So they haven't given us much at the beginning.
But they gave us C6H9.
They gave us the end. So I reckon we work backwards.
Okay, where plus M to form anion Z binders, which is protonated. The key to form the key intermediate Z shown below. Z I plus HBr to form compound Q. The final stop. I mean, they gave us Z, so can we not work out what Q is?
You can't. You can work out Q from this.
Okay, so I want to do Q first.
Okay, sure. We can do it in any order. Just
So-
follow the arrows.
So the BR goes here.
Yeah.
There's the bond here,
Yeah.
and wait, that gets kicked out.
Yeah.
Does that?
Yeah. Because the bond is going to the oxygen, isn't it? So there's going to be no.
Oh,
bond.
and that forms water.
Yeah.
Oh, so that's the minus H2O.
Yeah.
So the Q is gonna be BR.
Yeah.
Wait.
The BR doesn't connect to the BR doesn't replace the carbon. It connects to the carbon.
Yeah, I know.
Okay.
So it's like this.
Okay. You're gonna have to. Okay. Fine.
Oh, I mean, okay, fine. It's like this.
Yeah.
Yeah, I always do like dumb stuff.
It's fine. Ooh. That's a nice triple bond.
Wow. Only the best from G-Les 1. Is that Q?
Yeah,
Wow,
that's correct.
you did Q. It's tweaked.
Ah.
It's
Okay, that's fine. Just move on.
Okay, so we did part 3.
Yes.
Draw a curly arrow mechanism for the reaction between Q and R.
Damn.
I think we'll leave that to the end.
Okay. You've seen that before. It's halogen plus nitrogen, isn't it?
Plus nitrogen.
Yeah.
Have I seen that before?
Imagine if that was NH3.
That you just replace it.
Yeah.
Oh, fine. Okay. So we have C6H9 minus.
Yes.
So it would have been C6H10.
Yeah. But there's a lot of isomers of C6H10, isn't there?
But we can use double bond equivalents. There's 3 double bond equivalents.
That's not a lot. If you look at this thing,
Well,
you know what that is. So you know what L could be from
well,
that.
I mean, the thing is, we're given that M is this, and that looks a lot like this.
Yeah.
So if we connect that over here.
Yes.
Wait, how many carbons are there in this? So there's, not counting this, we have 1, 2, 3, 4, 5, 6.
Oh. Okay.
6. C6H10 is 3 double bond equivalents. No, 2. Oh wait. So I'm gonna have a wild guess and guess that it's like this.
Yeah, that is it. That's it. See, it's all about guessing. You just gotta see the pattern and then guess.
Wow. Draw a curly arrow mechanism for the reaction between L minus and M to give Z minus.
Oh my gosh. What?
Oh, we have to draw a curly arrow mechanism. Oh my
Yes.
god.
Curly arrow mechanism.
So
Okay, firstly, what you need to draw L minus and draw a curly arrow mechanism to form L minus from LH. Don't you? So what's if that's L? What's L minus?
L minus, if I had to guess, would be like minus.
Yeah.
Yeah.
Do they care if you do like fractional balancing?
No.
That's fine. Yes, exactly.
So that means the hydrogen disappears. But with H plus, that means that means there's gonna be what do you call it? There's gonna be a double bond on the carbon.
Double? You mean lone pair?
Lone pair.
Okay, so how does it react with M?
Wait. We have to draw the curly arrow mechanism. So
okay.
it's like this.
Yeah.
Okay. How does it react with M? That's a very interesting question. And oh wait, it's still minus. Now the thing is, the minus I think gets transferred. Wait, where does the O come from? Oh, the O is here. I think the minus gets transferred onto the O.
Yeah. Good guessing.
Oh. Wow. So I think I always like to draw out our reactants and products.
Yes. Good for step.
and I think Z minus the structure of Z. By the way, is my skeletal alright?
It's legible. That's all it has to be. It's fine.
Ooh, does the double bond stay? I don't know. No, I think the double bond goes away. I think this happens. I think it's like this. If I'm being honest.
Yeah,
Yeah.
that's it. I mean, it's like Legos. You just gotta see where it connects, and then cast your way.
C3L6 is like Legos, which means if you want to get good at chemistry, guys, just play with Legos.
Exactly.
Yeah.
So the entropy question is like they forgot times the combustion by 2.
Yeah.
Okay. Draw a curly arrow mechanism for the reaction between Q and R, and hence draw the structure of protonated
Turbinafine.
binafine.
Okay, this actually seems a bit hard.
Oh, well, we know Q is that, and we know R is that.
So obviously something goes on with the N, right?
Yes. But it says protonated binafine.
Protonated.
That usually means it has a charge of +1 and it has a H attached to some atom.
Could turbinafine just be like this?
And what's the point of Q? You just made Q using like 5 steps. You need to react them together.
My bad. Guys, I got another idea. What if Harry, Prof G's hand. Oh, it's my handwriting, Harry. It's what if it's just like this? Like you connect it here, and
Wow. Okay, well, I mean, if we're talking in Lego terms, that would be connecting a smooth brick to a normal brick. You have to see where the studs are. If you look in chemistry, the reason why organic chemistry exists, is because
yeah, go on.
it's because the carbons and the hydrogens don't like anything else. They're like the lone wolves. They're the sigmas.
Okay.
But if you have other things like nitrogens or bromines, they're the beta males. So they need to go. They need to fight to become the alpha.
Okay. Okay. So
Yes.
So you were saying how if this is like NH2, it gets replaced with the Br.
Yes.
So where we scrap all of this.
Okay, wait. Don't... NH3, I mean. So I'll give you a hint. NH3 plus
Don't draw up here. Don't draw up here.
NH3 plus Br equals
H2N.
H2N plus HBr.
Okay. Now the problem here is we have NH.
Or, how does H2N react with HBr? What does it make? It makes H3N plus and Br minus. Doesn't it?
Yeah.
It's acid base.
Wait, is there any world in which you have a BR attached to an N?
No. The Br goes off. The Br goes away.
So are you saying is that this BR just
Yes.
like goes away?
Leaves.
It
Yes.
becomes irrelevant.
Well, the BR just leaves.
And this H also leaves.
Not necessarily.
NH3 plus, Br minus.
Hmm.
So, okay. From that what I'm gathering is that
Okay. Yeah.
is that this is plus. The N here is a plus.
Well, in the product it is. Yeah.
Yeah, in the product it is.
So how many bonds does it need to have to?
Four.
Yeah, 4. So what's it bonding to?
Like the BR.
But the BR left. The BR went to buy milk. Okay.
You know, Man will call this haram, but I'm gonna draw the bond over here.
That's perfectly reasonable.
So
Yes.
so it's like this.
Yes. 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 Yes.
Is that actually it?
Yeah. It literally told you the PR went away.
Wallahi. Okay. Say wallahi, bro.
Wallahi. Wallahi. Wallahi.
Okay, wallahi, let's draw this curly arrow mechanism.
Okay.
Bro, we spent 20 minutes on this page.
Go on.
Is this supposed to be an easy question?
No, it was hard. I didn't get it in first year.
In first year.
I actually did it.
Shut your mouth.
How do you not get this in first year, bro?
Oh,
What a...
I didn't know what curly arrow was. So yeah, it's a shame. It's a shame. Come on, Barack. I believe. I believe in you.
Okay. Let's think about this.
What type of reaction is it?
What type of reaction?
Yeah. It's one of the reactions we've learned before. We did it in today's lesson.
Elimination.
What got eliminated?
The VR.
Did it make a double bond?
Wait,
What's this reaction called? What's NH3 plus Br
like
plus ethene?
solve.
Ethane. Yeah, it's a nucleophilic substitution. So what's the nucleophile?
The NH3.
Well, it's the N, isn't it?
Yeah.
Because the N has a lone pair.
Yeah.
Where does it attack? You need to join the N to a carbon to make the final product. So it's like Legos.
So
You need to join it at the correct carbon.
so I'll go here.
Yes.
Okay.
Okay.
Wait. Let me think.
That's good. That's
What
good.
does that do? That
There's one more arrow remaining. There's one more remaining.
hello, uneven person. I'm gonna say this.
Yes!
Yeah. Wait, what?
Congratulations.
Bro, this is why I hate organic, bro. Get everyone some mole calcs.
Organic is the best because it's just gas. But you can't guess more counts.
You can
And-
work out mole calcs.
Yeah.
You can't.
So you can both guess and work out organic, but you can only work out more counts.
You can't work out organic. I'm sorry.
So you guess it.
I'm sorry. My guessing abilities is not that good. Okay.
That's why you need to practice. Get good at guessing.
Oh. Okay, bismuth.
Should we have a 1 minute break?
Okay, let's have a 1 minute break.
I'm gonna ask them Subway stuff.
You're actually like, let's go ahead. There's oral questions, man.
Huh?
It's just like, well,
But it's easy.
I'm gonna overlap from whatever the fuck I was doing here. I don't know what the fuck.
Composition questions.
Fine.
Bro, I got. What version did I get wrong? I got
You don't
these.
need You just need to be able to copy and paste.
I thought it was annoying.
So this can be fun. I know that. Even though it's got that F
Yeah, I'll send past.
it doesn't matter. It's all be fun.
Alright, this is going fine.
I
I think that's too much.
lost all my marks in this section by more.
Bro, for this bit, I had no fucking clue what I was doing.
I actually frauded.
Yeah, I know. What the fuck is going on with boron spectroscopy? I just chose the 2 and CL.
Well, yeah, that's
Which is a higher number. Like,
I think that's pretty frauded.
yeah, it was either that or that. Like, you just guess we were fucking random.
Well, no. You just need to. Why is it all CL? It's going to be close to the CL.
That's how you do it. I wasn't thinking, I was just like, a bigger number
Yeah,
is going to
yeah.
be CL.
Well, I mean, yeah, kind of. Okay, let's talk about the crazy chemistry of this year. Choose it.
Is it 2023 paper?
Yeah.
Oh, fuck's sake. That's the one I thought. Shit,
I mean, the only one I couldn't do in organic was the last one where she was like crashed out and started talking. No, it's not hard. It's not hard. It's just like.
Is there any like Dodger like torturism, or is it just
No, but you have this, which is like what is going on here, bro? Like,
no? I've seen that in multiple questions though. Like, just,
This was special because you see
Oh, no.
it's on cruises, right?
like
That means
like,
I've seen it in some questions.
Okay.
so like
I'm not getting this. I'm sorry. I'm just
Neither
not getting.
am I? We're gonna get cooked. But like, who's even watching?
Harry.
It's just Harry Shet.
Okay.
Are you just giving a private lecture to Harry Shet?
Yeah, for real.
Sup, Harry?
When heated in a flow of chlorine gas,
No, it's just
bismuth forms bismuth 3 chloride. So you need to write your state symbols. So I'm not gonna write my state symbols. And you might be thinking, how do you know it's BiCl3? Because it literally says 3. Wait, Bi. Where is Bi in the periodic table?
It's in nitrogen's group.
It's in that group. Which means what's the one angle in NH3? Or what's NH3? NH3 is like pyramid. It's pyramid. I'm gonna say 95 to 108. Is that right?
Yeah.
Cool.
Why?
Now the reason why is because Bi, as you see, has 5 valence electrons. It's got these bonds to Cl, but as we found out in the last question, in order for the formal charge to be 0, you need an extra lone pair. So this lone pair means there's 4 bonding pairs, which means it's tetrahedral. But tetrahedral is 109.5, I hear you say. But the thing is, electron, because this lone pair is close to the bismuth, it kind of repels all the other shits. So the bond angle is actually like less than that.
Yes.
Great. And this question is just +5. Bro, the bit where they give you experimental data is they give you experimental data and it's kind of cuss.
But like, this question is like, you've just written the ion of boron, and then it makes you rewrite the ion like a very slightly
Yeah,
different
yeah.
form. I'm just thinking, what's the catch? And it spooks you, you know?
Bro,
But it's the same as in GCSE.
Nah, right?
Sometimes they ask you.
They just moved the fucking like 4 of the options to an OH ion, and we're just like, we called it a day.
Well, maybe that might be targeted towards the grade 2 students.
But no way the grade
Whereas-
get into the bit with the fucking.
Yeah, that's why they have to put it at the start. And then later it's for the grade 9 students.
But it's not the start, it's like
wait.
question.
So I think maximum oxidation state.
Mm-hmm.
Realistically, it's probably gonna be like fluoride.
Mm-hmm.
Is it fluoride?
Fluoride.
Yeah.
What are you even talking about? Yeah.
Now I have no idea why it's fluoride, except I know that fluoride likes to be reduced.
Well, fluorine is the most
It-
oxidizing agent
Yeah.
in the
Yes.
entire periodic table.
Yes.
Yes.
So I was right.
Yeah.
Okay. Let's go. We're actually cooking, bro. We're cooking so hot. Currently, I've only gotten this one wrong. So
You're on track for 95%.
Am I on track for a gold?
You're on track for RG. You are.
Okay. Why is it over this form of bismuth? Oh my god, I have to scroll on the periodic table.
Oh. So bismuth emits an alpha particle.
So bismuth
Doesn't it?
is 83, so it's gonna go 81, which is
Yeah.
TL.
TS. How are you talking about TS?
What was TS? You know TS is like TMUA support.
What? TS. TS is polysulfonal. Yeah, group.
You told me.
Yes.
By the way, an alpha particle is is 2 protons, 2 neutrons. So its mass number is 4. Oh, is this?
Is it the same alpha particle as in the Rutherford scattering experiment?
Is it? I don't think so.
Why?
I actually don't know what they used.
Didn't they use alpha particles?
Oh, I thought you were talking about the isotope.
No. The alpha particle.
Yeah.
The alpha particle is the same. Alpha particle.
Trimethyl bismuthane.
What?
Bismuthane.
Wow.
For the complete combustion, this is mad enthalpy number 1.
Oh no.
There's mad enthalpy number 2 in 2024. But that's what I'm saving the best for the last.
We're gonna do that as well today.
Bro, I've done every past paper.
Damn. Wait, did you get RG?
I got RG in some of them.
How many? What percentage?
I think
70%.
yeah, probably.
70%. I think you have a good shot.
But like, it's getting harder to get RG.
Yeah, so that's why you need to do the questions and think about them.
Okay. Lock in. Combustion. BiCH3 plus. Oh wait. Plus O2. Is it plus O2?
What do you mean? Yeah. With combust. So what does Bi go to?
What does Bi go to? Well,
Yeah.
I'm looking at this, so I'm gonna assume it's that.
Yeah, so you guess.
Is this W frauding?
Yeah.
Half Pi2O3.
Plus how many CO2?
3.
Yes. Plus how many H2O?
9.5.
9/2.
Oh yeah, 9/2.
Yeah.
I wrote 9/2, bro.
Okay. Now to do the Hess cycle.
Wait, no,
Or
no,
you can do
no,
the
no, no,
products
wait,
minus
look, bro. Wait. How many oxygens are there? There's 12, right?
Why do you want the oxygen in the first place?
Because it asked for the equation.
Okay. Yes.
This one was the one with the battery spillage.
Did you not put new batteries? Oh, that's what you're asking me. It's
No, I'm asking batteries for my mouse.
Oh.
Is it 6 oxygens? Tell me, yes or no?
Oh my! Did you count? Well, clearly you're gonna have half an oxygen from the 9.5. Oh, from the 9.5 H2Os. So you're gonna have 3. Oh no, I'm stupid. So it's 12 over 2 plus 3 times 2 equals 6 oxygens.
Okay, so it is 6.
Yes. This is why I don't like calculations, because you have to do them.
Okay.
You get very getting vibes.
No, I don't. Well, I mean,
No, he does. He
You're just like, it's still what it looks like.
gets full, proceeds to get full marks
Oh,
if you
God.
round up to the nearest integer. If you round to the nearest integer.
Yeah, but my vibe didn't work, did it? For the half mark.
Okay, so enthalpy is change of formation of BiCH3L. Now, do you know what fraud I like to use?
What?
I draw an arrow here called like elements.
Yeah, that's what everyone does.
Is that what everyone?
That's a good thing.
What you first what my sense?
Elements.
Oh. Yeah, I
Because
elements as well.
elements doesn't have any
Yeah,
formation combustion.
Yeah, no
enthalpy.
one gonna be like.
What elements are they?
Yeah, no one gonna be
Yeah,
sitting
right.
there writing out each individual and go like C brackets graphene.
Exactly.
In A level, unfortunately, you can't write elements.
Yeah.
Yeah, but just tank it. Do it as a form of,
It's not worth.
do it as a form of protest.
It's not worth the pride.
No, it's not. It's not worth the 1 mark you get for writing them all out.
Okay, so Bi203, so that's half of minus 574. So 3 times minus 394. Minus 4.5 times 286. And I guess if we're going this way, it's plus 2912. Okay.
Can I put something on this?
No.
Please.
No.
Please. Why don't? Why not?
Because wait, does this seem right? Plus 156.
Probably. Standard enthalpy of formation of BiCH3 sounds about right. Sounds about right.
I checked all of these right. Like minus 4.5 times this, 3 times this, half times this, plus 2912. Yeah?
Seems right. 2912. Wait, what? Oh, yeah.
Yeah. Okay.
Yeah.
Okay.
Yes.
And
Oh my god.
now it's time to find the average BiCH3 bond.
I'm hot. I'm just...
Okay, now this is where writing elements might not help so much because you have to write because it matters whether it's in the gas phase or not,
Yeah.
which really sucks. It really sucks.
Yes.
What is this like one of those loop things?
Yeah. It's has cycle.
Yeah. We could just write elements and just hope for the best.
Who doesn't love has cycle?
So
But it matters which state it's in.
Yeah, we just write elements. It's just elements solid, elements gas.
so my idea is to go from
Your
this
idea is very good.
to 3CH3 gas.
Yes. Well, you don't need to put the bracket. But yeah, that's it.
Okay,
That's the average bond enthalpy, isn't it?
times 3.
That is the yes, indeed.
Now, okay, so okay, we have this BiCH3 liquid, the vaporization, which I'm assuming turns it into gas, is plus 35.
Well, you can write it as the symbol.
Juice, what was that thing you were explaining, like if it's a third earlier? I've never got that. I've seen it in multiple.
What do you mean if it's a third?
Like the hydrogen is accounts for like a third charge.
Bro, just listen to what I say. Just listen to what I say and trust.
So
No. If you consider the 2 electrons,
Yeah.
and you're gonna have to trust me on
oh
this.
my god, mate, that's the very roundabout way of doing it.
No. You have to trust me. Imagine like n of those electrons, where n is not necessarily like a whole number.
Yeah.
Imagine n of them go to a hydrogen, and 2 minus n of them go to an oxygen.
Yeah.
And then you can just think about it.
So we're treating in terms of just large numbers.
So if it's 2 minus n, then the oxygen. Okay, no.
So basically,
Yeah.
H3O plus. The
Yeah.
total charge is plus 1.
Yeah.
And it says the oxygen has a negative charge. So the oxygen has a small negative charge.
Yeah.
So it can't be positive, can it?
Yeah.
So the hydrogens have to share the positive charge. So
Okay.
if oxygen has 0 charge, then for the entire thing to be plus a third, each hydrogen has to be.
Yeah.
the entire thing has to be plus 1, each hydrogen has to be plus a
I
third.
want to know, is it approximately a third or is it exactly a third?
Well, because the oxygen has a small negative charge, each hydrogen has to have a bit more positive charge to cancel out the small negative charge.
Okay, so it's
So
approximately a third.
So it's a bit more than a third.
Okay, when would it be exactly a third? Is it never exactly a third?
In real life, probably not.
Okay, cool.
Probably, yeah. Okay. Sour cream and chive dip. Sainsbury's Ruller cheese, 125 grams. Wow.
Atomization. Why do we need? Wait, why do we need atomization? Oh, to turn into. Oh my god, that's so gay.
What?
Oh
Wait,
no!
what-
Oh
what are
my
you
god!
doing?
Oh my god!
What is this? What is A?
Huh?
Oh, okay, fine.
Wait, but Bi to CH3 bond strength, is that BiC or BiC plus 3CH?
It's the Bi to C bond in BiCH3.
Oh my god. So I'm gonna say that's BiC plus 9
Wait, what? Wait, okay.
9CH.
What? Yeah, that's the amount of bonds it has. Okay. Yes.
But it gives you the
That's always off.
no.
Just so people can not be bored.
Fuck you. Okay. Is this supposed to be easy?
No, I didn't get it.
Bro, you're so bad.
Yeah, I know.
I don't get this one.
What?
It's just NMR, but it's just they mixed a bunch of shit together.
Yeah.
I just don't get
What? It says the peak heights
Yeah.
show the relative proportion. So you know they have the same peak height. That's probably the same molecule.
Oh, what the fuck?
Oh wait, it's 3 carbons. There's 3 carbons. See- No.
Come on. The thing is, we have 2 viewers. We have 2 viewers.
This will
It
drive
doesn't
the
matter.
2 viewers away.
No, but it means that if more people click on, they can stay for longer.
Please don't. Bro.
Who's the other viewer?
Please. I don't know.
Xander.
Please.
No, he's under now.
Xander said he would.
Ah.
Please.
Okay,
please,
you do it.
Please,
then.
just
Ah.
let me log in, please. Okay, the endomere formation of CH4. So C solid plus
C solid plus blah blah blah. Yeah, of course it is, mate.
Fucking idiot.
Of course it is. Of course it is. Alright. You could have opened it from here.
Hmm?
Why did you not open
I
it from
don't know.
here?
This is B, right?
Wait, let's see. CS plus 2H2. Gas. What happened from that to that?
Hmm?
What happened from that to that?
Oh, wait. Nothing. No.
Do you know what I would do? Or do you want to figure it out?
I mean, I kind of want to figure it out.
Okay.
But do you really not get an atomization of carbon? Oh no, you don't need that.
Oh,
3 carbon. Oh, you know what I'm gonna do? I'm gonna write 6H2 minus 3 over 2H2.
why would you do that?
It's just haram.
It's fine, but it's just a bit hard.
Okay. So if we go Bi gas, Bi gas plus CH4 gas minus 3H. So let's think about what we're doing here. We're turning Bi into a gas, so that's we're doing E to that. We're doing 3C plus 6H2 to CH4, so that's 3B. And then we're minus 3 to H2. And turning H2 gas into just gas is wait, for atomization, is it per 1 mole of H, not H2, right?
It's
Per mole of H.
I would say it's per mole of H.
Yeah, okay. Bro, you're supposed to know.
Yeah, it is. But I mean, it's debatable. But in A level, it's per mole of H.
E plus 3B minus 3D. Lol, for C3L6, just check your work from Adavia.
Bruh! Wait, is it all year?
No.
Ay.
Don't worry, you'll get first. You'll get first in the country. Don't worry.
What do you mean? I'm one hot. I've dropped off since last year.
That is not. Blood got 82 out of 84 in Chemi Olympiad and says he's dropped off.
Yeah, it's C3L6.
It disgusts me.
It does.
Too much thinking.
Guess.
But I'm not very good at guessing, you see.
Well, then you need to practice. You can practice guessing. You can't practice thinking.
But like, guessing requires thinking.
Yeah.
And to break CH4 off into the bonds, hair cycle is kind of annoying though. For real.
I agree.
CH4, the bond strength in CH4 is F, so it's 4F to remove them. So I'm gonna say 4F. Is that right?
You must have used A, B, C, D, E, F.
I have.
Okay, then what's the answer?
So I'm gonna say, and then you also have to divide by 3. Bear in mind. You also have to divide by 3.
Okay.
So I'm gonna say minus a third. Minus a third. A third. 1. Minus 1. And 4 over 3. Does that sound right to you?
I mean, it sounds reasonable.
It sounds reasonable? Oh wait, no. What am I doing? It's not 4. It's 12.
Oh my days, why? Oh, I missed Chaz.
No, you sent it to me as well. Oh my god. Yeah, because you're breaking 12 CH bonds. Okay.
And indeed. That's...
And now you have to use your value. You have to use the value.
Yes.
So we got plus 156.
Yes.
So minus 156 plus 3, minus 75, minus 35 divided by 3, minus 218.
Yeah, that's 2023. Yes. Yes.
Plus 208 divided by 3, plus 4 times 49.
So it's minus a third, plus 1, minus a third, minus 1, plus a third, plus 1. That is the answer.
Wait, so how many did I get?
You got 5 out of 6.
Wait.
That was very impressive. That's quite impressive.
Wait, what did I do? Oh, because here it's CH3. It's CH3. You're only making one bond. Is that every carried forward for the next part?
No. There is not.
Fuck you.
Ah.
Bro, okay, I think that's the RG gone.
Wait.
What are you doing?
Oh, wait. Let me.
What are you doing? What are you doing?
Let me just
What
see
are you-
something. Let me see something. Let me see something. Come on, please.
Well, what are you gonna do? Tell me what you're
Subway
gonna do.
Surfers.
No. We're not doing Subway stuff. You can't.
Oh, I want Subway Surfers. Oh,
You're such good. You're good. You're such a good individual.
ah.
Okay, that's 142. Okay, unit cell.
Oh my days.
Oh my god.
I think we should skip the unit cell question and go to the next question. Or we can do the unit cell question and then skip the next question.
Okay, I mean, let's do unit cell just for the.
Yeah, I think unit cell comes up pretty frequently, and that's one of the things they didn't teach you. So,
Bro, you know I got this in first year.
really,
Yeah.
damn.
Okay. The 3D shape outlined in black is a right rhombic prism. How many? Can we please not?
Okay, keep doing it. It's fine. Keep doing it.
Okay, so as you can see, only a quarter of this unit cell is in the thing. So I'm
Yeah.
gonna put a quarter on these. I want to. Oh wait, are these all a quarter?
What do you mean?
Are
You
they?
get it in first and you can't do it now.
I don't know if this is inside the thing.
Which one?
Can I read this, please?
Okay, I'll turn it down.
Please turn the volume down. You can turn the volume.
Okay.
Yeah, the 3D shape outlined in black is called the right rhombic prism, which consists of four rectangular faces, two faces which are rhombi. Okay, so this is also a quarter. I gotcha. Make the subway surfer bigger.
Yeah, that's what I've been saying. That's what I was saying. That's what I was saying.
Oh my god.
That's what I was saying. Look, now we have 4 viewers.
I'm on the verge. We used to have 5. We used to have 5.
Oh,
we had 5.
my days.
We had 5.
Come on, let's just put it on.
1, 2, 3, 4, 5, 6. Bro, what happened to my self-esteem? Is it 6?
What's the total number in 1? What do you mean? Which one's inside or outside?
I think there's 8 outside.
1, 2, 3, 4, 5, 6. There's 6.
Is
You
it
can just
6?
count it.
Okay. Calculate the mass in grams of the atoms contained in 1 unit cell.
Yeah.
Oh my. This is so haram. There's 6 atoms. Bismuth. What's the MR of bismuth?
Oh my god.
208.98.
Subway surfers.
Bro, how did you sit through BMO2, bro? You see, you turned it off and now it's 5 viewers.
No, that's just because they're gonna leave soon.
Divided by Avogadro, which is 6.0. Is it 6.023 times 10 to the minus 23? Is it point? Yeah.
Times 10 to the power of 23, not minus 23.
Oh sh.
Avocado is big.
Oh, my bad.
Wait, and is it true that in Subway Surfers, if you have a curved coins, you always get more coins than if you have straight coins?
I think so. I used to play Subway Surfers. Now the volume in angstroms and centimeter cubed, that's kind of terrible. In terms of a useful thing is that the area of a triangle with side length L is root 3 over 4L squared, which means the rhombus is root 3 over 2L squared. Is that right?
Yeah, I presume so.
Times 4.535 squared is 17. So the area of this thing is 17.81. And then we times it by 11.814 to get 210.4 angstrom cubed. Or 2.10 times 10 to the minus 22 centimeter cubed.
I agree. Yes.
So the density is going to be 9.89. Do you agree?
Density, I would presume yes.
Okay, let's we have 6 minutes to do the rest. Okay, now it's real crunch time.
Wait, it's been 90 minutes. We're meant to have completed it.
Well, yeah, but we took a break, and also you blasted Subway Surfers in my ear, and also we started the stream late, and also I would have skipped organic. BiCl3 reacts with water to go to BiOCl plus 2HCl. Trust. That shocked the lady who entered the... We have 7 viewers now. Let's see how many viewers we have after you do this shit. Bismuth 3 sulfide. Bismuth 3 sulfide is B2S3. So BiOCl plus H2S, I think. in the Harrogate waters. Is this right? There's 6 hydrogens, 2 O's. So I'm gonna say 2 HCl plus 2 H2O.
Yeah.
Okay.
Wait.
You see,
what's
now
your
we have
answer?
5
What's your
viewers.
answer?
Now we have.
Yeah, that's because I took the subways off.
This is right.
2 BiOCl plus 3 H2S AQ. Bi2S3. 2 S H2O 2 HCl. Yeah.
Okay.
Yep. You're gonna get RG, I believe.
Calculate the empirical. I'm more likely to get RG if you don't fucking do this shit. We have 2 viewers. We have 2 viewers. Choose what have you done.
Okay, I'll put some summers away.
What have you done?
It's just because they're not viewing it anymore. They'll come back.
83.85. Oh my god. Divided by this. You always do the percent divided by the atomic mass. So that's like 0.4. And the unit cell, what the fuck? Chlorine. Chlorine is like 35.5. What's 100 minus 83.48? 16.52 divided by 15.35.5. Wait. Is this thing bismuth and chloride? Those are the only things. What's the MR of chlorine?
35.45.
Okay, it's 4.5.
You can't divide answer again. What's the question?
.466. And what was the bismuth? Was it 208.98? Okay.
Okay.
0.399. Oh my god.
So divide 0.466 by 0.399.
.16. So it's like 6 to 7.
Huh?
It's like 6 to 7. It's 6 to 7.
Yeah. 6 to 7. They predicted 6-7. How?
Okay.
How?
Now we calculate the MR of this. Oh my god. 1502.03. So it's gonna be BI 24 CL 28. I was better in first year than I was now. Calculate the charges. Okay.
That's just, you can just guess it.
So BI2 CL8 2 minus. BI CL5 2 minus. The bismuth atoms. Now all the chlorine. Oh my god, we have to solve fucking Diophantine equation. So there's 1 of these. There's 4 of these. There's 2 of this. 4 of this.
What are you talking about?
Is that right?
2 of what?
That 1 of BI2CL8, 4 of BICL5.
Okay, so it's just 1 and 4.
So there's gonna be 18.
2 and minus 2 and minus 8. Is it?
No, like the charges are 2 minus 2 minus. And I'm gonna say it's BI18. Wait. BI9 2. I think. What the fuck? Okay. Bi2Cl8 1. BiCl5 4. Okay. So this is 5 plus. Bi9 5 plus. Yes.
Yes.
What's the balanced equation? Oh my god. 4Bi. No, not 4Bi. In molten bismuth chloride. What the fuck? 28 over 3. BiCl3. What's 24? 24 divided by...
Wait, how did you even get that so quickly?
Because it's 28 divided by 3.
Why?
Because there's 28 CLs.
Oh. What an equation. That's taking balancing equation to the max. Wow.
Oh. Is this right?
Yeah, probably. I'd say it's right.
Oh. Wait, so what questions did I get wrong?
You got like 2 marks wrong.
I got this wrong and I got the organic wrong.
You're in RG.
Is that RG?
Yeah.
Wow. I guess this paper was... I can't believe how much I clipped from this paper in first year.
What do you mean? What did you get?
I got a silver.
Ah.
The stream ended.
No.
Ah.
So, do you have any tips before the big day?
So, I mean, organic chemistry is like building Legos, I suppose. You just have to like piece it together. And then also don't be afraid to make guesses. What else? Like check your answers if you have time.
Read the questions. Read the questions.
Yeah, read the question. If you find a question difficult, don't just like leave. You can just skip it and do the other ones. Because the rest of the questions probably won't need the previous question to answer. So you should always persevere. But yeah, that's it for me.
Yeah.
Notification.